Yes, I will only shortly introduce the topic of design thinking. Design thinking depends here on customer business technology information in order to generate successful innovations. Thereby, different kinds of design thinking processes are known. These are agile-like approaches where you, by understanding the problem, observing it, and defining points of view, creating a problem space, and by defining then ideas, generating prototypes and testing these prototypes, you find then solutions for these problems. And yeah, like I already mentioned, this is like an agile-like approach where you can go forward and back to find then the perfect solution or the perfect innovation. Yeah, and Christine will continue.
So in the design thinking process, there are a number of ways to make the design thinking process more concrete, to really make it more easy to understand and to visualize it. And so in this on this slide, you see a big box called scenario examination. And the idea is to create a usage scenario where you really set the limits for the user of the experience to be investigated. So you define each step, but how do you do this? And the method that you can use is called the AEIOU method. And that divides the methodology into different activities. On the left-hand side, it's the activities. Then you consider the environment where it will happen, the interactions that are happening, the objects with respect to which those activities are happening, and who's doing it, who is the user. And then you really put yourself in the shoes of that user and you think what you will do. And that's called a cognitive walkthrough. And you define the process steps. So in step 1, you do X, step 2, you do Y. And then to really visualize it well, you can use a swim lane illustration where you can imagine the flows of what's happening. And my colleague will take you through that process.
So yeah, if we take the example of the car in a parking garage scenario, and we go through this cognitive walkthrough, sorry for this cognitive walkthrough of the experience for the user. So then we start by selecting the parking preference, and then we communicate it to this ecosystem. We identify the user upon entering the garage. Then you will enter the garage, look for your parking spot, then park the vehicle. You will maybe get a feedback for how you parked, and then you will get out of your car, leave the garage, and then do your shopping or whatever, then come back to the garage and find your car again, trigger first you will pay your parking, then look for where you were parked, unpark your vehicle and leave the parking, verify your payment and leave the garage. This is kind of what it will go through for the customer. And now Astrid will explain a little bit how some of these steps can be decomposed for the AIOU method.
Yeah, perfect. So once we have identified our activities within our sort of car parking scenario, we can then apply the AEIOU method and define sort of the respective requirements that we have there. So for example, for looking at an assigned parking bay, we need certain, a parking guidance system. We need maybe a certain lighting system. This will apply to a certain user group, and there will be also sort of interactions within the different systems. From this on, then having sort of sketched out these requirements, then we can sort of start to create our product.
I start all again. So we have now learned that we've now got this usage scenario that is assessing to each process step the according activities, environments, interactions objects and users, and from there it's only a small step to identify the technological tasks that are required to deliver the customer benefits. So as we know, since we are IP guys, that the solution to technical problems are actually called inventions, and some of these inventions can be made exclusive by patents, but we've also learned that we have to think these IP protection process from the perspective of the customer benefit instead of from accidental inventions. So what we have here is somehow a delineation of the important aspects of technical inventions, like those who are really contributing to the customer benefits, from those inventions that may be challenging or fascinating or delighting the developers, but are actually not contributing to any customer benefits. So here in this example, we have got a list of possible non-trivial trivial and non-obvious tasks. For example, recording the user's parking preferences to identify free parking spots, or to direct the users into these parking spots. And now we have like a technical to-do list of the technical problems that have to be solved to generate the user benefit, to create the customer benefit.
So yes, as Jan mentioned, now we are more focused on the technical side, the invention side. So now the task is to transform the real life activity, what the customer is, or the user is doing, a real life task, into a technological task in terms of technology and then invention, possible invention. So here in the example we have for the task, parking a car in a parking bay, looks quite simple, but behind we have a lot of technological aspects. We have, for example, to identify a free parking space, which can be done by the technology with some sensors. Or we have also comparing the parking space with the vehicle dimensions. With, for example, also sensors. You have a laser or camera which can measure the dimension of the space to make it more simple for the user to determine the ideal position of the vehicle in this parking space, marking out the customized parking space and providing assistance with the parking process. So all this task can be done by technologies. So we can try to find if a patent is possible here. So of course you must check the prior art before going further.
Okay. In this slide, we look at another method for identifying alternative technical requirements and attributes in order to understand how user requirements and the desired user experience can be achieved. So, for example, in terms of vehicle space requirements, priority should be given to vehicle size. Another example would be with the display marking, which could have mechanical and optical attributes. And we can have these placed within the vehicle side. And this approach can be cross-referenced with the considerations for substitution, the substitution element in the sales methodology.